Hi! Today we will learn how to apply trigonometric ratios in solving problems involving right triangles. Are you ready? Let us recall first. We have the trigonometric ratios in SAW, CA, and TOA. These are really by definition. Knowing SOHCA-TOA, it can help us solve real-life problems involving right triangles. To remind ourselves, we can write them like this. So, sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. Just remember, so, ka, TOA. I mentioned a while ago that we can solve problems involving right triangles using these trigonometric ratios. Let us apply them on this example. Benny Boy is on his way home. While he is near his house, he saw his pet Siopaw stuck at the roof. Meow! Oh no, what do I do? He said. He tried to look for a way to save his pet. While searching, he saw a 10-foot ladder resting below their window. Then he thinks, if he will place the ladder 5 feet away from their house, at what angle should the ladder make to reach the roof? We can solve Benny Boy's problem by applying trigonometric ratios. Let's see. We know that the ladder is 10 feet, and he wants to place the ladder 5 feet away from their house. So, if we are going to take a look on the illustration, we can form a right triangle just about there. See? Now, let us use the triangle for our solution. As you can see, we already have the value of the hypotenuse side, which is the length of the ladder, 10 feet. We also have the measurement of the base, which is 5 feet. Since we are looking for this angle, we can now label the 5-foot base as the adjacent side. Having the hypotenuse and the adjacent side, which trigonometric ratio do you think is applicable to find the measurement of the angle? Ka! Very good! Now we write cosine theta equals adjacent over hypotenuse. By substituting the value, cosine theta equals 5 over 10, or 1/2. With this, what angle that when you get its cosine, you will arrive to 1/2? Well, it will probably be useful to use a calculator. The way that we'd use a calculator is we would use the inverse cosine function. We will rewrite this as inverse cosine of cosine theta is equal to the inverse cosine of 1/2. Why are we doing this process? By multiplying the trigonometric inverse of cosine, the cosine function on the left side will be eliminated, giving us a new equation. Theta is equal to the cosine inverse of 1/2. But we don't know the cosine inverse of 1/2. That is why we will use our scientific calculator for this. We plug in, shift, cosine, look for the fraction symbol, then type 1 over 2, close parenthesis, and then press equals. And there you have it. Theta is equal to 60 degrees. Therefore, Benny Boy should form the ladder in a 60-degree angle to reach the roof and save his pet Siopaw. Awesome, right? Let's have another one. A surveyor is standing 73 feet from the base of the Rizal Monument. The surveyor measures the angle of elevation to the top of the monument as 30 degrees. How tall is the Rizal Monument? How tall is the Rizal Monument? Have you been there? How are we going to solve this? Let us analyze the problem. Based from the given, we have the distance between the surveyor and the monument and the angle of elevation to the top of the structure. We are tasked to find the height of the monument. Since the angle is located at the bottom, the ground distance will serve as the adjacent side, and the measurement that we are looking for serves as the opposite. Therefore, the trigonometric function that we are going to use is tangent. Correct. Now we solve. Tangent theta is equal to opposite over adjacent. Substituting the known details, we have tangent 30 equals x over 73. Isolating the variable using cross multiplication gives us 73 tangent 30 equals x. From here, we will use our scientific calculator. We will plug in the details just the way it is written. 7, 3, tangent 30, close parenthesis, and press equals. That's the answer in radical form. To see the decimal form, we press this. So, if we are to round off the answer to the nearest whole number, the height of the Rizal Monument is approximately 42 feet. Cool, right? Now you try! For practice exercises, just enter this link to your web browser. I hope you learned something new today!